Welcome to qnawire.
Problem 740. A 2 kilogram block is pushed against a spring with negligible mass and force constant K equals 400 newtons per meter, and it compresses 0.22 meters. When a block is released, it moves along a frictionless horizontal surface and then up the frictionless incline with a slope 37 degrees. That's not really to the best scale. But what is the speed of the block as it slides along the horizontal surface after having left the spring? So part A. So part A, it's a straightforward conservation of energy problem. We have the potential elastic energy is going to be equal to the kinetic energy of the block after it is released from the spring. So to do that, it's just going to be 1/2 k x squared is equal to 1/2 mv squared. And then we just need to substitute everything. So our mass is given as 2 kilograms, K is given as 400 newtons per meter, X is the distance compressed, and we're solving for V. So if we plug in all those values, times 400 times 0.22 meters squared, equal to 1/2 times 2 kilograms, velocity squared, we get V is equal to 3.11 meters per second. Okay, then for B, how far does a block travel up the incline before starting to slide back down? So what we can do is we can again write what the conservation energy between the block in position as it is over here versus over here. And the difference here is that it has kinetic energy and no potential energy. If we set this to be y equals 0, or potential energy equals 0, gravitational potential energy equals 0, and up here it has stopped before it starts sliding back down, so its kinetic energy is 0. So what we can do is we can set equal to kinetic energy initial. So I'll write 1 is equal to U2, or the potential energy in the second position. Okay, then what we do is we write what these are. So we have 1/2 2 kg times 3 meters per second. That should be 3.11 squared is equal to our mass times gravity, so G times the height. Okay, so then writing now what this is, 1/2 times 2, that's just 1. So 3.11 squared is going to be 9.68 joules, equal to 2 times 9.81 times h. So that's meters per second squared. We get h is equal to 0.49 meters. Okay, but then what we need to do is we need to find how high up the ramp it actually is, because we're asked how far a block travels up the incline. So what we can do is we make a triangle that's a right angle, and we know that we have the distance here. So this is h. So we know what h is, and we know what this angle is. So what we can do is we can write down that we have the opposite length, 0.49, is equal to the hypotenuse d, which I'll write d here, sine of 37 degrees, and therefore we get d is equal to 0.82 meters.